Today I'm looking forward to discuss data munging and wrangling using Python Pandas. And for this Python programming, I'm going to use Jupyter Notebook as my IDE. And you may feel free to use any IDE of your choice. And as we know, the first statement is going to be import pandas as PD, as we are going to use pandas for all our data manipulation. And once I have done that, I'm going to import a CSV file, and for that syntax is going to be read CSV, which is one of the most useful method in pandas. And I have a file already with me, and the file is location weather short. It's a CSV file. So I read the CSV file, and I'm going to store the information into a data frame df0. Okay, let's go ahead and execute this. Once we execute this, the first line of the file contains the header. So it is showing us the header here, and it shows the data right below. And if you notice, there are a lot of NaN here that is not a number. So if the CSV file contains null value or blank value, or even NA with a slash or without a slash, still those information will be taken in and it will display as NaN. Great. So far we have read the CSV file, converted to a data frame, and I called it data frame 0 as it's the raw data as is, and I am showing that on the screen. Well, now let's go ahead and see the data type of these columns and fields in this data frame. So here, if you notice, I have a command type df0 that will show me the data type of the whole data frame, that is data frame itself. And then I have a column date, and for that the data type is series. So basically every column in the data frame is of type series, and in that the data type of the date field, the first position or the first cell is date 0, and that one is string. This is an important thing to note. Date normally should be of type timestamp, but here it's string. That means you can't do date parsing, you can't do date logic and all that stuff. So we have to convert this of type date, and soon we will do that. And here we have one more column location, that's also series, and if you take one of the cell on that, that is of type string. Excellent. So far we are able to get the information, and we are able to see the data type for those. Now, since the date field is not in the form of the right format, it is of the type string, what we need to do is we need to parse the date. So we are saying pandas that when you read the CSV, there is a column by name date, and when you read that, you need to parse every field, every cell, you need to parse it and identify the date and store that in the form of a timestamp. Let's execute this, and I am creating a new data frame 1. And if you notice here, the date field is formatted different because it is for the date field and the timestamp. Okay. So now that we have this, let's run the same data type command and see what we see now. Okay, so when I execute this, um, the data frame that is the same, series is same, but here the data type of one of the cell in date column is timestamp. That is what we wanted so that we can do all date logics. And for the other one, which is location, it continues to be string because we haven't disturbed it, right? So far good. So let's go ahead and insert few more rows by pressing in the B key. Okay, so now after that, what I want to do is I want to say use date as a index, because when we do lot of logic, it becomes convenient to arrange data, to sort in the sense arrange and do any manipulation, interpolation, all that stuff. So I'm going to say set index the column date and use the same data frame df1, and in that same memory location um, make this change of index. So when we execute this and see the output, we see the date column is coming first, and that is part of index, and the remaining non-key columns are also shown here. Okay, so this is perfect. That's the way we wanted. We wanted the date to show up as index, and also other thing non-index columns to show up next to it or after that. And previously we had a running index here 129, and now that is been removed and we have a date index itself. Okay, now that we have seen how to change a date index and all that stuff, let's go ahead and see how we can fill the empty ones. Okay, we see lot of NaN and all that stuff, but we want to fill them with some useful information. So whenever I have a empty or an NaN, and what I want to do is I want to fill that with any particular value. Okay, so let's say I have this command. I say fill NA, that is not a number, you fill those with zeros and show me the output. So here, wherever you have nan, it will update that with zeros. Okay, so this is the way I am telling Python that whenever you see non-useful information, because I want to do some data manipulation, I want to display those as zeros. Okay, but then I think about it. Do I want to set it as zero? Does it make sense? Or why don't I set it to some useful number? But what should be a useful number? How can I say which is the right number? So I don't know the right number. So the best approximation can be average of all the wind speed, average of all the precipitation. So what I do is I take the wind speed average, and whenever there is no value, I use the mean as a value. Same thing for others. Precipitation. Then I have T max and T min, which is the temperature maximum and minimum. And I say fill NA for every cell, every column, and so I use a dictionary. Is a key value pair. The key is location and the value is unknown location. Wind speed, the value is the mean value of wind speed. So I do this logic. This is pretty neat, that whenever we don't know, we take the average value as our best approximation. Okay, so when I do this, and let's see what the output is, and our output is that every cell has value, and the date is not in sorted order, but it is a date field timestamp, and every cell has a valid values. So initially all these positions were NaN, now they are filled with the average values. Perfect. Moving forward, um, do I want to do this way? Does it make sense to fill with average? So let's say we are taking temperature into account, and in the month of January it's freezing cold, in the month of July it's burning hot. How can you put an average across the year and put that is the average temperature? So I don't want to do average. Instead, what I want to do is forward fill. What is forward fill? Forward fill in the sense, what was the yesterday's temperature, I would copy it over to today. That's more meaningful, doing a forward fill. So if I execute this command, here if you see fill NA, and I say fill method is ffill, which is forward fill. So this is the first value which is available, and after that every value is copied or forward fill, right? So this is a neat way to do that. I keep filling forward until a data is available. So whenever we need any data, we do forward fill, and this goes across the rows or across the days. So by default it is going top to bottom or across all the rows, and if you want to force it you can say axis equal to rows. Anyways, now sometime we don't want to fill across rows, you want to fill across column. Is there a way we can do that? And can we fill backward? Yes, we can do both backwards and across column. The syntax is going to be same. Fill na on that particular data frame 1 method is backward fill across all columns. Okay, so if I execute this, see, this is actually funny that the wind speed 6.26 got filled for location. So basically computer is doing backward fill across column, and computer doesn't care whether it's a meaningful information. It says you asked me to do backward fill, here is the result. Okay, so it is our responsibility to do the right way. Okay, moving forward, what we are going to do is we did the backward fill, and then we did the forward fill. We did the axis, we did the column. But now I think about it, it doesn't make sense if we are going to do fill for 10 days. So we should say it's fair to assume for one day we have to do forward fill. So if I don't know today's temperature, I can take yesterday's temperature, but I can't keep doing it for 20 days forward. So here is the next logic, that I say forward fill with a limit of 1. That means, let's look at this. So here I say data frame fill na fill forward with a limit of 1. So that means this will is not going to fill the extra ones only one time. So here we had 0.26, it filled one time, and that way we got it. Okay, and then these were still not completed. Similarly here it was 6.26, it just came down by a day and filled it, and this one it didn't do it. Okay, so this is a good feature. Sometime you want to do forward fill with a limit of 1 or 2, whichever you want, you can do that as well. But sometime if I think this is not the way I want, what I want to do instead is interpolation. So I have one value here, I have one value below. Why can't I take average of just those two values? That's even better. So we can do interpolation by taking the average. Okay, and for that there is a very simple method on the data frame, interpolate. Okay, so I say data frame 1 interpolate and write it into a data frame 7, and when I do this, what it's going to do is it takes every value and it sees above and below. So let's take this one, 6.26, 6.04, and these two were not available, so in steps it's bringing down 6.18, 6.11 and 6.04. So that's the way it's doing interpolation. And if you notice, for the precipitation there is no bottom value, so it just carries over flat. Okay, so the computer does the best way to interpolation based on what information is available. Okay, so we are done with a simple linear interpolation here. And the other thing what I want to do is, sometimes we feel it's too much of hassle to do interpolation in this way. Why don't we drop the cell we don't want? So for that we have a simple command, drop na, it will drop everything which has NaN. So there is only one row on the top which is a perfect row. Other than that, every other row has some cell with NaN. So only the top one gets displayed. Okay. Now I think about it.
this is too strict that it's dropping pretty much every row. I don't want to drop every row. I want to drop based on certain condition. So I put a condition, drop only if all the cells are nan. When I say cells, non-key fields. And when I execute this, it is going to show me something like this. So it dropped few record but not all. So these one, see, you have value here. For these rows, you see you have value here. So each cell, each row has one or few data points. So we are not going to drop those. So we drop only other than date, every other cell is nan. Okay. But these two are two extreme scenarios. So you see, sometime you drop only if all rows are nan, sometime. So what we want to do is we want to keep a threshold. So how do we put a threshold? So way you can put a threshold is we say that drop, we need 3 or more valid values, and if it is less than 3 valid values, it's no good. So if I execute this, see, every cell has at least 3 valid values. So if this one you see 48, 33 and NY city, and if in this one you see this is nan, 8.72, 35 and 32. So we have at least 3 valid values. So that's the threshold that you can put a threshold condition. Okay, now that we are done all this threshold, let's think of something else. I want to sort these dates, and I also want to fill any empty dates in between. How can we do that? So for that we have a interesting logic. Let's do that. What I'm going to do is I say I create a date range starting from December 9th to 21. It will create the date. I put that date into a DatetimeIndex method in Pandas and put that into a ID, basically date index, IDX. And I say use this IDX to reindex my data frame. If I do that, let's see how the output comes up. Now I have the dates from 9 to 21, and since the 9 was not in the initial set, it puts all nan. Similarly 21, it's putting all nan because those were not in the initial set. The remaining data was in the initial data set, and it takes over and fills it up here. Okay, so this is pretty neat that it's not only sorted, it's also filling in the empty ones. Okay, now that we have it, let's say we want to do some data manipulation. Okay, so I want to search and replace. In Excel we can do that, and why don't we do that in Pandas too? Okay, so if you want to do that, then there is a library I have to use, NumPy. Okay, so when I use NumPy and I say replace, whenever you find 0.26, replace that with nan. So it's like in Excel, search and replace, you can do that. And because that's not a valid value and I want to do that, so when I execute this, it will search for 0.26 and it will replace that with nan. Okay, moving forward, um, it's not just one value. I want to replace two of those. Let's say 0.26 and 35. Okay, then how do we deal with that? Here you see there's a 35. I want to replace that with nan. So I can pass a one-dimensional array with those two value, and I say replace with a nan. So in that case, a new output comes up like that. Okay. So the 0.35 which was here, I think that's gone. Okay, but now comes, this is too very flexible. We want to make it restrictive. On this column search and replace this, on this column you want to do that. How can we do that? For that we have to use key value pair in dictionary, and we have to do that. So the way to do that is something like this. Take my data frame temp, replace in the column location, okay, when you find nan with New York City. Okay, similarly in the column wind speed, if the value is 6.04 or precipitation is 1.57, replace that with nan. Okay, so let's do that. So let's check. We have 1.57 precipitation, we have wind speed 6. I don't 6.04 is here. So let's see what happens. So 6.04, that got replaced with nan, 1.57 that got replaced with nan. So this is like field level validation, field level replacement, all those kind of stuff, which is pretty neat way that in Python you can use a dictionary and you can handle those. Okay, now going forward we want to do interpolation. Okay, in interpolation we saw that we can do linear interpolation. Now there is a time weighted interpolation. So let's say we are doing the weather. We know the weather on Thursday. We don't know the weather on Friday, Saturday, Sunday, and we know the weather on Monday. So being a holiday or whatever reason, we don't have. So now when you want to calculate the weather, what it will do is it will give the weight or interpolation based on the time. You want the weather only for Friday and not for Saturday and Sunday, it would see how many days and it would weight accordingly and it would do that. So when I execute this, see this is time weighted interpolation. So if I remember right, so let's see, we have 6.2, oh no, so whenever it's doing interpolation, so these cell I think 6.26 and 3.8, no 5 point, let's be accurate, yes, 6.26 to 3.8, 6.26 to 3.8. So everything below that is interpolated based on time. So it's just stepping down the wind speed on every step. And if you notice, it's not able to do interpolation on the first one. So it still leaves it as nan because there is no time weighted calculation available. On the other hand, on the last one, it just takes the prior value and it displays that. Okay, so now here comes the last command of this video. So here what I am doing is find the cell NYC and replace that with New York City, that's a full form, and wherever I have nan I want to replace 99.99. If I execute that, it's going to show me New York City, and when here it shows 99.99. Okay, so here we learned how to read a CSV file, put into a data frame, then how we can do any data manipulation, search and replace, interpolation, different ways of interpolation, dropping the cells if there are none, how to put limits and all those things. If you have any questions, please do leave them in the comments and I'll be happy to get back to you on that. And I would request you to subscribe to my channel if you haven't done before. That's it for today. Thank you and have a nice day.